audience. Why do skunks make good bankers? Because they make a lot of sense. Okay, we're moving on. Okay, did I tell you about when I was dating that banker? I dumped her because I lost interest after a while. Okay. I didn't really. Okay, so, and you like that one. So this is called 6-1, B. This is law of signs, ambiguous case. Ambiguous case. An ambiguous case is when you do have side angle. Okay? So if you have a triangle, I gotta find my notes here. If you have a triangle and you're given a side angle, there's 3 things that could happen, okay? Or 4 things actually. You could, whoops, I don't want that to be done. You could have, so this side, you don't know how long this bottom side is. So I'll just put an arrow on this bottom side somewhere. This is just kind of a ray, okay? And then you could have an angle going up this way, or a side going up this way with some angle, okay? And usually they call this angle A over here. And then you have another side hanging down over here, okay? So if this side is too short, so say I know that this is side A, and this is angle A, and they call this side B, will just, according to this picture, will this make a triangle? Will this make a triangle? Probably not, okay? And the way you could figure that out is by finding the height of this triangle. So I'm going to make this a dotted line, okay? If I were to drop down a height right here, okay, and I'm going to call that height H, okay, sine of angle A is equal to H over B. You understand that? Okay, so I'm looking at this as a right triangle right here, this right triangle, and so B sine A equals H. But if A is less than H, we don't actually have to find out H in this case. If A is less than H, then you have no triangle. So I'm going to do an example. I'm going to do 3 examples. So this is case 1. You understand that? If I find, so this is fixed, right? This thing is rigid, it can't move. Okay? And side B is rigid, it can't move. And side A, it could swing back and forth, right? But the only thing that's fixed is this angle and this side and the length of this side. That's why it's called the angle side. So this angle won't move. This side stays where it is. This side, since this angle isn't fixed, it can swing back and forth. But if this side A is less than H, then it's not going to reach, right? And so in that case, you would have no triangle. Follow that? Yes? Good. Okay. So we'll call this like case 1. Case 1. Case 2 is if, let's see if I can, oh, where'd my thing go? Whoops, where'd it go? I'm coming back. For some reason. So case 2 is if I have this side here, oh, I don't want dotted line. Dotted line. So in case 2, no, I said dotted line, solid line, solid line. Go back. Oh, now I have to. So in case 2, if I go like this, and here I'm going to drop down. I'm going to put this side over here, okay, and here is, we're going to drop down H this way. We'll make H a different color. Okay? So if this is H, and again, this is A, this piece is fixed, this piece is fixed, this piece could hinge, and this is a right angle, and this is A and this is B. What if A is equal to H? A is equal to H. What does that mean?
It's a right triangle.
It means it's a right triangle. I can only have one solution. Okay? So in most of these cases, you're going to have to use this formula, sine of A is equal to H over B, to find H. And then you make some determination about how many triangles you have. Okay? So if A is equal to H, you have one right triangle. Okay? I'm going to call that case 2. You understand that? So if this is exactly equal to this, it's going to slide down and it's going to match up here, right? And it's going to be exactly one right triangle. Yeah? No? Maybe. Okay? We're going to go on to the next case. Okay? Case 3. So let's do this again. Solid line? Is that a dotted line? Solid line. We want. Let's make this one. What color? That. Okay? Here we go. Case 3. Here I have this side. Here I have this side going to here. Okay? And in this side, they're going to give you, here's angle A. It's fixed. Can't move. Side B, can't move. Side C, or, sorry, side A over here. Side A over here. Well, what happens if side A is, and this side, well, it can move, but it really can't move. If side A is bigger, whoops, that should be a little b as well. I keep messing up. This should be a little b. If side A is bigger than side B, how many triangles can I make? Exactly one. Okay? One obtuse triangle. So if this side opposite the angle they give you is bigger than this side, right? If this is fixed, it has to exactly touch here. It's rigid, right? It won't make anything. So if A is bigger than B, you have one obtuse triangle. One obtuse triangle. We'll call that case 3. Case 3 with Roman numerals. Okay? Case 4 is the one that it gets everybody messed up. Okay? Case 4 is really the ambiguous case. Although you have to check. So here you don't have to check for H. As long if this side is bigger than this side, then you automatically know that it doesn't matter what H is. It's gonna make one triangle, right? Okay? Because if anyway, let's just I won't get you more confused. So the next case is case 4. Okay? And case 4 kind of looks like this. So we have this triangle. We have this being, I'll draw this kind of like this. And then I'll draw this. I'm going to draw down the right, no, it's, there's this piece going this way. And then I'm going to draw down H going down this way. Okay? So here, in this case, this is H. This is A. It's fixed. Side B is fixed. Little side A is only given one length. But if A is bigger than H, if A is bigger than H, or A is less than, but less than B, then I have two triangles. Okay? So, and let me see if I could drag this one. So if I had two triangles, I could either go this way, like that, whoops, That's no good. Let's see if I could stretch them. Can I stretch them? There we go. Okay. If this is side A, this looks more like an equilateral triangle. But side A is bigger than side H, but less than side B. So he can either stretch this way, or it can go, side A can go over here. I'm trying to be insistent. Side A could go over, oh, it's going to make it red. I don't want to make it red. I want to make it black. So, or side A could swing this way. Okay? Do you see that? If this is side, so if A is bigger than H but less than B, it could either swing out this way and make a triangle, or it could swing inside of B and make another triangle. Do you follow that? I'm going to show you with a physical demo, which I can't show the viewer. For example, we'll do a couple examples here. So that's what happens when you have two multi-boards. Solve. So we're gonna, I'm still going. Did I forget to put? No, I'm good. I'm good. So, so they'll say like, solve the triangle. And they'll say A equals 22, B equals 12, and A equals 42 degrees. So the first thing you do is you draw a picture. Huh? So where's that nice tool I had? Freehand shape. There we are. So you draw a picture and something like that. There, that's not a very good triangle, but it's good enough. Does this? We have to do this again for some weird reason. Okay, and then your first step should be to find H. Okay, so here's H, and label all your sides. So big A, this angle here is 42. This little b, we're going to call 12 over here. And big A, little a over here, we're going to call 22. Is that right? That's right. Right? A is 22. Oh, how many triangles do I have? One. Why? So B is bigger than A. One triangle.
You mean A is bigger than B?
Yeah, you're right. Sorry. A is greater than B, so you have one triangle. And then you could just solve the triangle using log signs. You don't even have to find H in that case, right? So you just say sine of 42 is to 22 as sine of B. We'll call this B. Sine of B is to 12. And then you take the inverse sine of 12 times this, so you get B is equal to the inverse sine of 12 times sine 42 divided by 22, and you get that that angle is about equal to 21.4, okay? And then you could figure out what this angle is up there, right? And then we'll call this, so this is 22.4. You do a little geometry, and you figure out that angle C is about 116.6, and then you could say sine of C is to little c as sine of A is to. Okay, do I need to go through all that? No? Yes? You can do that, right? Go like this. Okay, go like that. Okay? So then you have one triangle. I'm not going to do if, well, let's do another one. Okay? So I'm going to give you a couple more pieces. They'll say A equals 25, B, that's wrong. I wrote it down wrong. A equals 15, B equals 25, and angle A equals 85 degrees. And they'll say solve the triangle. So you draw a triangle again. Tools, freehand shape. Here's a triangle. Here's one side. Here's another side. Here's another side over here. Okay? And so if I call this 85 degrees, let's flip it over here. Should I flip it over here? No, let's keep it consistent. And I tend to be pretty much, even though my drawings may not be to scale, just to keep things straight in my head, I always call this A, okay? And I always call the side opposite A, little a, okay? And then I always call this B, and I call this 25, okay? Well, I'm going to draw the height in over here, okay? And I'm going to find H, okay? And if I do that, I get that sine of 85 is equal to H over 25. So H equals 25 sine 85 degrees. That's degrees, that's degrees. Okay? And I get H is about equal to 24.9. 24? Oh no. Oh, I was looking at the wrong thing. Well, if it was 24.9, okay, is this what's going to happen if H is 24.9? How many triangles? No triangles. So little a is less than H, right? So no triangle. Do you understand that? Because it's kind of like this thing is sticking straight up here, and if this is almost 25 or 24.9 or something, this little side here isn't going to reach the ground, right? Not going to be able to make it. So this side has to be bigger than 24.9 in order for it to. Questions on that? Okay, now we're going to talk about the ambiguous case. You should really pay attention on this one, because most people, or I'd say about 50% of the people, get this wrong whenever I give a test on it. Okay? So, so solve the triangle A equals 12, B equals 31, and C equal, or sorry, big A, angle A equals 20.5 degrees. So I'm going to draw this here, not dotted. Let's try that again. Not dotted, solid. So is it dot? It's not dotted. So this is 20.5. B is 31, A is 12. So here's a, let's just draw this one, okay? So if this is 12, we'll call this as A, and B is 31, and I call this angle B, and I call this angle A, which is 20.5. First thing I want to do is find the height, okay? Right here, okay? And I'm going to call this H, okay? So again, sine of 20.5 equals H over 31, okay? And if I solve this, I get H is about equal to 10.85, okay? So because side A is greater than 10.85, right? Which is the height, and it's less than 31, which is side B. Then I have two triangles. Yes? Okay? So A is between this. So first you have to find H. Okay? And so now I know, well, this is bigger than H, so it can go here. You could have one triangle, or I could have two triangles. Okay? And since it's between. So the way you find this angle right here, first case, you just do it like you're doing it normally. You go sine of B over 31 equals sine of 20.5 over 12, right? And I cross multiply and I get that angle B is equal to the inverse sine of 31 times the sine of 20.5, that quantity divided by 12. And if I do that, I get that angle B is about equal to 64.8 degrees. 64.8 degrees. And then I could find angle C is equal to 180 minus the sum of 20.5 and 64.8. Yes? Which is, what does that come out to be? That comes out to be 94.7, I believe. 94.7 degrees. Okay. So this is 94.7, and then you can go ahead and find side C by going sine of 94.7 is to C as sine of 20.5 is to 12. Right? Okay. The other case, now this is what people mess up on. The other case is if this 12 goes this way, right? So I could say that here's my 12 over here, right? In which case, guess what that angle is right there? If it swings this way, the other possibility is that angle B is equal to 180 minus 64.8. It's the supplement of what you found angle A to be. Okay? And the reason people say, why, how could that be? Well, sine, if you remember, that's not a good thing. If you remember, sine has two places where it's positive, right? So if this is 64.8 degrees here, both of these angles, so if this is 64.8, both this angle and this angle to here have the same sine value, right? Okay? So I subtract from 180 to find angle B. Okay? So if I'm looking at this other triangle, I guess I'm going to have to draw another triangle. So let's just get a new page. Well, do you want me to show you that? So let's see if I could draw it in right here so you guys could see it. The other possibility is that this triangle in miniature could look kind of like this, okay? Where this angle here is what? What's that angle? 64.8 minus 180, or from 180? 115.2. Thank you, Mitch. And you know that this is 20.5, right? And you know that this angle, you just subtract these two from 180, and you get this little angle up at the top. Well, it's not that little, but it comes out to be 44.3 degrees, okay? And then you know that this is 31 still, right? This doesn't change. And this is 12 still, right? So then to find this side, which people always mess up on, okay? Then instead of using the 94.7 up here like I did to find this triangle C, that triangle C's, I use 44.3. So I would say sine of 20.5 is to 12 still as the sine of 115.2. 115.2 is to 31, right? And then you find, sorry, I was, as the sine of 44.3 is to C. And then you have solved the triangle. Do you understand that? Okay, so you either find this angle normally and you say it's this acute angle right here, or it's the supplement of that acute angle, right? And then you solve the rest of the triangle. Then you find this piece, and then you find C. That's kind of it. I got to show you one more quick formula, and then I'm done. Okay. The last formula is it's this. If you have any freehand shape, where's freehand shape? Freehand shape. For any oblique triangle. Oblique means non-right triangle. For some reason it does this. I have to go back and do this. There we go. Okay. So for any oblique triangle, this is A, this is B, this is C, this is little a, this is little b, this is little c. This comes directly out of finding the height and using law of sines to find the height. It so happens that the area, this does not mean side A, the area of any oblique triangle can be shown to be BC sine A divided by 2, which is equal to, you might have learned this in geometry, A, you probably don't remember, AC sine B, especially if you had me because the jokes were so good and you just couldn't pay attention. Yeah? So B times C times the sine of A divided by 2, A times C times the sine of B divided by 2. What do you think else goes there? A, B sine C divided by 2. So what that says, if I multiply any two adjacent sides times the sine of the angle between them and divide by 2, I can find the area of that triangle, of any oblique triangle, not just right triangle. So what that does, it eliminates finding the height of the triangle, okay? And it's pretty easy to prove that that's true just by finding h, right? But you can find the height in a couple different ways, so that's all you have to know, okay? And that's the end. Do you have any questions on that formula? So that's it. We have 5 minutes. I have time to check your homework, okay? Pause.